Today we are going to discuss about projectile motion. So what is projectile motion? So we know that when we throw an object, then what happens? This object moves like this, right? Why it will move like that? Is there any reason behind that? Yes, we are having a reason behind that. Let us discuss about that. So okay. Right, here you see, here we are having the fountain, right? So then what happening here? This object is moving like this water is moving like that, right? So water is moving in this direction, right? Why they are moving like that? We will discuss it now. Right, you see here. You are able to see, right? Yes, very good. So here what happening? These are moving with certain velocities, right? Yes. So then what happened? These are moving in this direction and making a certain path. So those are called the projectile, right? Very good. Next. So here we are having the main definition of the projectile is that the projectile motion is considered as a vector superposition of the two simultaneous and independent. Here we need to take this one. Here we need to take this one. So projectile motion is considered as a vector superposition. Here we are having the vector superposition of the two simultaneous and independent of rectilinear motion. That means one-dimensional motion, right? So in mutually perpendicular directions which are completely independent from each other. So here what happens? Here to determine the projectile motion, first we need to know about the two-dimensional motion, right? So what is two-dimensional motion? It is nothing but the two one-dimensionals acting at one time. So we can call that is a two-dimensional motion, right? So here we are having the projectile motion, right? Projectile motion is considered as a vector superposition. What is vector superposition? Vector superposition. That means here we are having a vector and here we are having another vector. So then what happens? This vector is superimposing on this vector. So that means, so how much will be? So here this much. Just take the different color. Okay. So here this is superimposing. So here what happens? Let us take the name of this vector is B and this vector is A. Okay. So here what happens? This is superimposing. So the B vector is imposing on A is this much, right? So like that we are having. So here we are having projectile motion is concerned vector superposition of the two simultaneous and independent rectilinear motions in mutually perpendicular. Here we are having that mutually perpendicular. Mutually perpendicular means we know that. So here we are having a vector and another vector, right? So here what happens? This is one-dimensional. This is one-dimensional. So the combination of these two are our two-dimensional motion here, right? Okay. So here what happens? The vector superposition of this is on this object. Let us take the vector B here, a vector A and A. So what is the vector superposition of A on B? It is only dot, right? So here this is imposing, right? So here it is imposing like that, right? So if we take B superimposition, so then what happens? It's about here, right? So it is also a dot, right? Very good. So vector superimposition will be explained like that. Next, you will see here projectile motion is the motion in which an object is thrown near the earth's surface. Here we need to understand that near the earth's surface. What is near the earth's surface? Nearer to the earth, right? So projectile motion is the motion in which an object is thrown near the earth's surface and it moves along the curved path under the action of the gravity. So here what happens? When we throw an object, let us take this object. So this object is thrown. That means it will travel like this. Yes or no? Yes, it will travel like this. Why it will travel like this? Due to the gravity, it is pulling downwards. Yes or no? It is pulling downwards or not? Yes, it is pulling downwards. So for that reason, we are going to get the direction of the object is going to be like this. Yes, very good. So why it making only curved path? Why not it making a straight path? So here you see, here this straight person is doing like this. So he is moving like this. Why he is moving only this direction? Why he is only doing in a curved path, right? Why? Why? Because the here whenever we will see now. So here projectile motion is the combination of two motions. Combination of two motions. So the first one is horizontal motion. Horizontal motion with constant velocity, and the vertical motion with constant acceleration. Vertical motion with constant acceleration. So here we are having the acceleration. Acceleration due to gravity G. We have discussed in the gravitational chapter, right? So the G acts constantly on the projectile in vertically downward direction. So we have already discussed in the gravitation chapter there what happens there when an object is thrown upwards. Then what happens? The acceleration due to gravity is always acts towards the downward direction, right? We have discussed there, right? Next, here what happens? Here we are having the acceleration due to the gravity G acts constantly on the projectile in vertical downwards direction and gives its parabolic path, parabolic trajectory, constantly changing its instantaneous velocity. So what is instantaneous velocity? We have discussed that instantaneous velocity is that the velocity at any instant, right? Instantaneous velocity. That means the velocity at any instant is called instantaneous velocity. Right? Next we'll see here. So whenever we are going to discuss something, first we need to assume. Whenever we are going to discuss something, first we have to assume some concepts, right? So here in projectile motion, we are assuming that the effect due to air resistance is neglected. So here we are assuming that there is no air here. So if we are having the air means then the air force is applying on that object. So we are going to change the position, change the shape of the trajectory. So for that reason we are considering air resistance is neglected. Here we are neglecting the air resistance. Next one here, effect due to the rotation of the earth is neglected. So here what happens? Effect due to rotation. So earth is rotating, right? Earth is rotating. Then what happens at the time? So if it is rotating, that means the object is also rotating. So for that reason, we are also think that the effect due to the rotational motion is to be neglected here. Okay. Next, the acceleration due to gravity is constant over the range of the motion. So here we need to consider the acceleration due to gravity. So whenever in gravitation chapter we have discussed about that when an object is moving upside, right? When an object is moving upside, then its acceleration due to gravity is getting decreased, right? But here what happens? In this chapter we are discussing about the short ranges, or that means about the less heights. That means short range we are taking. Okay, so for short ranges, the acceleration due to gravity we are considering as a G value is equals to how much? G is equals to 9.81 into 10 to the 9.81 into not into sorry 9.8 meter per second square. So 9.81, you can also take 1 also. So mostly we are going to take 9.8 and it will be like 10 meter per second square we are considering, right? So here we are having G value is equals to 9.8. So up to where? Up to certain range only we need to take the G value is equals to 9.81 meter per second square, right? So if the height of the object is getting increased, then what happens at the time? Then the G value is going to be changed, right? G value is going to be changed. So for that reason here we are considering the short ranges. So for that reason here the acceleration due to gravity is taking constantly. Okay. Next we consider only those trajectories that are sufficiently short ranges. Here we are using the short ranges and short heights. Okay. So here if we take up to 1 kilometer, 2 kilometers, we can give an object to the velocity. So then what happens? This object will move upside. So for that reason what happens? The acceleration due to gravity, here we are going to get that 9.81 into 10 to the power 9.81 meter per second square. So here what happens? For short ranges and short heights, we are considering the gravitational force gravitational acceleration due to gravity, we are considering 9.81 9.81 meter per second square. So if the G is constant, that means the force when an object is thrown upwards, then what happens? The force is also getting the same. So mg is our force, right? So F is equals to mg. So m is constant, right? And g is also constant. Then what happens? The force is also getting constant, right? So here what happens? We consider only those trajectories that are of sufficiently short range and height, so that the gravitational force can be considered. The gravitational force can be considered constant. Okay, you got my point? Yes. Next we'll see. Here we are having motion diagram of a kicked football. So we all play some games, right? So then what happens there? Let us take cricket, right? So cricket means that what happens? Then a bowler will bowl the ball. Yes, bowl the ball. Now here you see that when a bowler is bowling, so then what happens? This ball here, I am starting, I am bowling from here. So the further distance what happens? This object will move like this, right? It will move here and it will hit on the ground. Then after it will move like this, right? So then what happens in the time? A bowler, so a batsman is also there. So the batsman will hit this. Then what happens? After this hitting, then it will move to somewhere else, right? So that path is also moving in this direction. In this path, it is going to be taken place. So then what happens that what we call that the trajectory of that path is called parabolic path. The trajectory of that path is called parabolic path. So here what happens? Here the object is, see here we are having motion diagram of kicked football. So here we are having the particle projected near the earth's surface with initial velocity moves along a curved path under the constant acceleration direction towards the center of the earth is said to be executing projectile motion. So here we are having this one, projectile motion is executing. So here what happens? A particle projected near the earth surface near with certain initial velocity moves along a curved path under the constant acceleration. Here we have discussed about the constant acceleration. So directed towards the center of earth. Directed towards the center of earth is said to be, it is executing simple harmonic. Sorry, it is said to be executing projectile motion. So here you see, here a person is kicked the ball, right? Then what happens? This ball is moving in this direction, right? So this ball is moving in this direction. So here what happens? Here we are having the maximum velocity. Here we are having the maximum velocity. It is moving with the maximum velocity from here. So then what happens? It is decreasing its velocity along the vertical. Along the vertical, it is decreasing its velocity. So along the horizontal, the velocity is not changing here. So for that reason, here you see, here we are having this ball, right? So this ball is moving in this direction. That means it is moving in this direction, and it is moving upward direction also, right? It is moving upwards. Yes or no? It is moving upwards. Yes. So here what happens? Here we need to understand that this object is moving upwards and in the direction of horizontal. So here we can consider that this is a two-dimensional figure. Two-dimensionally, it is moving. So here what happens? The projectile motion is considered into the two-dimensional motion, right? So here you see, here we are having this object is moving in this direction. So it is moving up to here, and then after it moved to here, and then after it moved to here, and here we are having. So here you see, here this object is moving in this direction, right? So what is the velocity here? The same velocity we are going to get here. The same velocity we are going to get it here. So let's take. So this object is moving upwards, right? This object is moving upwards. So then what happens? Here we are having the maximum velocity. So in the top position we are going to have the vertical velocity is 0, right? So and it is coming downwards direction, right? So it is coming downward direction means here at the point of the projection, then the velocity is maximum, right? So it is moving upwards and it is coming downwards. So then what happens? How much velocity it went, the same velocity it is coming downwards direction. Yes? Yes. Next we'll see. So all projectiles follow this thing of parabolic path. So everything, all the particles follows the parabolic path. So every particle follows the parabolic path. So here we are having a football, right? So here this football is we given certain velocity. That velocity is called initial velocity, and making the angle with the horizontal. So here we are having the horizontal. This is horizontal, right? This is vertical. Okay. So here what happens? This object is moving along the horizontal, and this object is moving along the vertical also, right? So it is moving upwards, right? Okay. So this object is moving with certain velocity. This object is moving with a certain velocity. That velocity is called initial velocity, and making an angle with the horizontal, right? So this is horizontal. So then what happens? Then after some time it will move to here, and it will move to here and come back to here. Okay. So here we need to understand some basic terminology. We need to understand some basic terminologies. Those are, so this V is called, here we need to use, mostly we will use U, right? U is initial velocity. So here we need to use U. So U, small u, that is U is initial velocity, and theta with the horizontal or vertical we need to think, we need to see. In the question we are going to get, sometimes we are going to get from the theta is from vertical, right? So here we are having this one, right? So U and theta. So these two, initial velocity and the angle of projection, will give the trajectory. Okay, so let us take, if this angle theta I would like to take 90 degrees. That means here, let us take, here we are having this one, right? So here horizontal direction. So here what happens, if I am taking the 90 degrees, an object is thrown with a certain velocity and making 90 degrees, then what happens, this object will move upwards and come back to the same position. Yes or no? Yes. So then what happens, there we are having the 90 degrees. That means this object will move upwards and downwards. That means only vertical projection is there, but no horizontal projection. So there what happens, there it will not follow the projectile motion. Will it follow the projectile motion? No. Why? Why? Because here it is, the angle is about the 90 degrees. So for that reason we are not going to get the projectile motion. Okay, right. So let us take an angle 0 degrees. Okay, let us take a 0 degrees angle. So here I would like to take a 0 degrees. Okay, so if the 0 degrees means here there is no angle between these two. So then what? There is no angle here. So for that reason what happens, if this object is given with certain velocity, so then what happens, this object will move like this. Yes or no? This object will move only like this. It will not move to upwards or any vertical direction. It will make only along the horizontal direction. But here what happens, here we are going to get the vertical direction, and here we are going to get only horizontal direction. Right. So here what happens, here you see, I would like to take another. Right. So here, when this object is moving upwards, right, in this direction, this object is moving in this direction. Yes or no? Yes. So here what happens? Here what happens? This object is moving vertical direction and horizontal direction. So let us take the superimposition. Let's take the superimposition. So this object is moving here, right? This object is on x-axis. We are going to see here. On y-axis we are going to see here. And we are going to see here. And next, if this object is moved to here, right, then here what happens? This object will move here and along the vertical, right, and along the x-axis. Here we are going to see. And if this object is moving here, then here we are going to see here. Yes. So, and here we are going to see the object here. Okay, so if this object is here, then we are going to observe on x-axis the object is here, right? If we are going to see the object at this point, then vertically, so we are going to observe here, right? So if this object moves to here, then what happens? This object will move to here along the vertical, and along the x-axis here we are going to observe. So if this object moves to here, then what happens? Here the object is along here, right? So if this object comes to here, then the object will be here. So along the x-axis we are going to observe here, and along the y-axis we are going to observe the object here. So then what happens if we consider the whole, if we consider an object is moving in the projectile motion, then that means along the vertical it is moving upwards and coming downwards. That means we need to understand that this object is moving along the vertical direction. That's it. Okay, and if we consider an object is moving along the x-axis here, so then what happens? This object will move in this direction only, right? Very good. Next, we'll see. Here, you see, here we are having that one. So analysis of projectile motion. Here we are having the projectile motion, right? This object is moving in this direction, right? And next here we are having the vertical motion, and this is horizontal motion. So if the object is moving in this direction, so for the reason we are going to get that this object is moving upwards. So along the vertical and along the x-axis, we are going to see here. So this object is moving in this direction. So Vy, and this is moving in this direction. So that is Vx, right? So here, this object is moved to here, right? This object is moved to here. So for that reason, what happens? This object along the vertically we are going to see here, and along the x-axis we are going to see here, right? So here we are going to see here on the x-axis, and the y-axis we are going to observe here, right? Next, if the object is here, right? So along the vertical we are going to see here, and along the x-axis horizontal we are going to see here. Yes. Next, we'll see. So here, if we move to here, then that means the velocity is in the downward direction. And here what happened? This is moving in this positive x-axis only. But here you see, here we are observing that the x-axis is moving in this direction and y-axis is in negative direction. So before that what happens? Before that it is moving in this direction. But here what happens? Here we do not have vertical velocity. Why? Why? Because to change its direction, we need to get the velocity 0 along the vertical. So here what happens? At this point, we are going to get Vy is equals to 0. While velocity along the vertical, we are going to get the 0 here. Okay. Next, we'll see. Here you see, here we are going y it is going upwards, so it is moving in the positive y direction, and this is moving. These are the positive x-axis direction, right? Next, we'll see. Here you see this object, this projectile motion is moved from here to here. Then what happens? There we got this object. It moved to upward and coming back to original state, original position, not state, it's original position. So for that reason, what happens? The velocity is downward direction. And here you see, here we are having this one, right? So it is moved like this, right? So for that reason, what happens? This object is moved, and here it is having. So here what happens? This is in the direction of the positive, right? So here we can compare that one. So here what happens? This object is moving in this direction, right? Here we are having the vertical, and here we are having along the horizontal. So here what happens? This object is moving upwards and coming back to the same position. And here you see along the x-axis we are having the displacement, but whereas in the vertical direction we do not have the displacement. So what is the displacement along the vertical? That is 0, and the gravitational acceleration is always towards the downwards. That means we are going to get the negative g. Okay, so here we are going to get the positive x-axis, and positive y-axis. Here we are going to get the positive x-axis, positive y-axis. Here we are getting only x-axis, no y-axis. Vy, here we are getting Vy is equals to 0, and here we are having x-axis, negative y-axis. Here we are getting x-axis is positive and y-axis is negative. So here you see, here while it is going upwards, the velocity is getting decreased. Yes or no? You see, here we are having this much velocity here I am going to have here, and here you see, here we are having less than this as compared to. Okay, so then what happens? These two are here. What happens? The velocity is getting decreased while it is going upwards, right? Velocity is getting decreased while it is going upwards. And next here at this point we got that the velocity is 0, vertical velocity is 0, and after this, immediately after this, the velocity is getting increased. So we know that in vertical motion, that means vertical direction, this object will move upwards, right? When an object moves upwards, after reaching the highest point, it will changes its direction, right? So after moving here, it will come back to here, right? It will change its direction. It will move upwards and it will it will change its direction and come back, right? With this come back to the same position with the same velocity, right? Next we will see here we are having the point of projection. So some basic terminologies we have to know. So here we are having the point of projection. What is point of projection? The point from which the object is projected in air is called as the point of projection. So here we are having the point of projection means the point from where the object is projected. So here we are having our object, right? So this is our point of projection. Point of projection. Point of projection, right? And next we'll see here we have seen that this object, this point is called point of projection. That means the point from where which an object is projected in air is called. So here you see, here we are throwing this object, so that means here, so let's take this one. So if I am throwing this one, right, so from where we are throwing this body is to be taken as our point of projection. Okay, next here trajectory. What is trajectory? So the parabolic path followed by the projectile in air is called a trajectory. So the parabolic path, so is this path is the parabolic path or not? Yes. So here what happens? This path is called the trajectory. Trajectory, right? So the parabolic path followed by projectile in air is called trajectory. Okay. So the trajectory of this ball here, the parabolic, right? Next we'll see the height. Next we'll see the velocity of projection. So what is the velocity of projection? So velocity of projection is that projection of object which is given projection with the velocity. So here we are having the velocity definition, velocity of projection definition. The velocity with which an object is projected in air is called the velocity of the projection, right? So here we are having that object, right? So this object is given certain velocity. So that velocity is called velocity of projection. Okay, that velocity is called velocity of projection. So here we are having theta. So what is this theta? Angle of projection. Angle of projection. So the angle of projection and the velocity of the projection gives the trajectory. So this is our trajectory, right? The trajectory of an object is decided by the velocity of projection and angle of projection. These two, on these two only the path of this object is going to be depend. Okay, next you will see here, you see this one, here we are having the velocity, right? This, let us okay, so let us see here we are having this velocity is given along this. So let us consider here x-axis and y-axis we have to consider, right? So here the velocity is given in this direction. So let us take let us write so let us write my initial velocity I am giving u. Okay, so making certain angle theta. So this theta indicates, what is that theta indicates? This theta indicates angle of projection, from which angle we are getting projected. So for that is we are going to call that is angle of projection. So here we are having this one, and here this. So this is our velocity along x-axis, that is ux, and this is velocity along y-axis, that is uy, right? So in vectors we have studied that when an object is in this direction, so it is making some angle theta. So if we are having this is u, that means we are going to get the cos theta. Cos theta value is equals to how much? Cos theta is equals to adjacent side, that is here we are having ux by hypotenuse is v, so u. So here we are going to get that ux. So ux is equals to u cos theta, right? So ux is equals to u cos theta, and along the y we are having this one, right? So what is y? Y is equals to u sin theta. And along the x-axis there is no acceleration due to gravity, and there is no acceleration along the x-axis. Here we are considering that along the x-axis we do not have any acceleration. So for that reason we are taking ax is equals to 0, and here we are having ay. So ay is equals to minus g. Why ay is equals to minus g? Vertically we are having the acceleration due to gravity. So for that reason we are taking ay is equals to minus g, and ux is equals to u cos theta, uy is equals to u sin theta. Yes, yes. So here we are having this x. X is that it is the displacement, right? X is equals to in last class you have studied that equations of motion, three equations of motion where acceleration is constant. We have studied three equations of motion. So what are they? One, v is equals to So we have used that when in a constant acceleration we got v is equals to u plus at, s is equals to ut plus half at square. Let us write here v square minus u square is equals to 2as. Yes, we have seen this one, right? So by using this we have find out the value of x here. So let us substitute the sx here, sx, ux, ax. So then what happens? Sx. So we want the x value, right? So Sx is equals to, thank you very much.
माँ 20 मिनट्स पढ़ा दिया